Hello, my lovely viewers and my dear students. Welcome back to my math distance learning class. In my channel today, we are going to continue with the new series of the topic of set that we have started a few days back. And in continuation with that, I have the second video for all of you today, which is going to be on the topic of different types of sets. So let's get started. In part 2 of the chapter set theory today, we are going to discuss what are the three different types of sets, and in the session today we are going to focus on empty set, finite set and infinite set. Before we start the topic for today, let me give you the learning objectives. Today in the lesson we are going to understand the different types of sets, namely finite set, infinite set and empty sets, and furthermore in the session today you are going to see how you can solve problem on these three different types of sets. So let's start with this discussion on the three different types of sets that we are going to be discussing today. The first one is called empty set. It also has a name of null set or void set. Next is going to be the finite set, and lastly we are going to discuss on infinite set. So let's begin in detail with the first set now, which is empty set or null set or void set. Okay, so this is the easiest set of all which is possible, and as the name suggests, this set is going to be empty. When I say this set is going to be empty, what I mean to say is that this set will not have any element. So a set without any elements, which contains no elements, is said to be an empty set or a null set or a void set. So these are going to be three different names for the same thing. So don't get confused if you see the name null set or void set in a question. Remember, it is just the same as the empty set. Coming to the notation, how you are going to write or how you are going to denote empty set is this one. So you write it in this way. This symbol is called pi, and it is like a circle with a slanting cross strike through that circle. So that is your empty set or your null set. You can also write this void set or null set in the form of just putting the two curly brackets with nothing in between. So it shows that it is empty and does not have any elements. So this is the notation you should remember, and let's see some more on empty sets now. Okay, so on this slide I have an important question for you. Sometimes students get confused by this question, so let me clear that out for you so that you don't make the mistake. So if I ask you, is this set, the set with the element 0, is it an empty set? Think about it. What should be your answer? Yes, you are right. This set is not an empty set because it has one element which is 0. So this set actually has a name which is called singleton set. So it has just one single element, that's why it's called singleton set. And as you can see, that element which is there in this set is just one, which is 0. So it is not an empty set. Please don't get confused by this. And let us now see some questions which you can expect from the topic of empty sets. Okay, so for example, you get a question about this set A which is given here, and as you can identify, this is given to you in the set builder notation. I will read out the set for you. Set A is defined as the set of all x such that x is less than 1 and x belongs to the set of natural numbers. Now I'm sure you will remember we had done some special type of sets. So this capital N is denoting your natural number set. And I would want you to think that is it possible that you will get any value of natural number which is less than 1? Think about it. If you want to wish to pause the video, you can do that. And then we are going to discuss the correct one. Okay, so I'm sure you know what is the smallest natural number. Yes, you're right, that is 1. So there cannot be any natural number which is going to be lesser than that. Therefore, this set A is going to be an empty set. There is no natural number which is less than 1, which makes this set A as an empty set. So that was an example, and I have a note here for you. So the concept of empty set, it plays a very important role, a key role in the study of sets, just like the role of the number 0 in the study of number system. So it is something very, very important that you should remember. I'm going to try one guided practice question which I have taken on empty sets from your textbook. So it has two parts, 8A and 8B. Let's discuss both of them. If you want to pause the video and try solving the question yourself, that would be an excellent thing. So I will read the first set. So set A, how it is defined, let's see. Okay, so set A is defined as a set of all x such that x is a natural number and it is divisible by 7. Okay, so if a natural number is divisible by 7, can we say it is going to be of this form? The set of all x such that x equal to 7n, where n is a natural number. So if I'm able to write, this is the set builder notation that I've written for the 8A part. And if I'm able to write this in roster form also, then definitely the first number which is divisible by 7, if I take the n value as 1, is going to be 7. If I take that n as 2, it is going to be 14. N as 3, it is going to be 21, 28, and so on. And because we know that the set of natural number is an infinite set, so this is going to continue. That's why I have the dot, dot, and dot, the ellipsis form. Okay, so I close my set here, but remember this again, set A is going to be an infinite set because this set is taking the values from the set of natural numbers. So again, it is an infinite set, and definitely you can see it is not at all an empty set. So let's conclude. So the final answer for this one would be that A is not an empty set. Definitely it has so many values. In fact, it is an infinite set. Okay, let's come to B part now. So I'm going to just use a different color, maybe yellow. Yeah. So for set B, how it is defined? It is the set of all x such that x is a human being who lives on Mars. Okay, now, so we all know about Mars. Mars is a planet where life is not there. Life is not possible. It's a red planet. You all know. So is it possible that there is going to be any probability or any chance of a human being living on Mars? Definitely no. That is why till now, because there has been no research of life being found on Mars, so we can safely say that our set B is going to be an empty set. And what is the reason? The reason is because there is no life which is possible. In fact, at least we don't know about it. There has been no research on this. So we can safely say no life on Mars and therefore no human beings. So that's what makes it an empty set. Let's now discuss, students, the next set, which is infinite set. So here I would like to ask you one question. What do you mean by the word infinite? And that is what would help you to remember and understand about infinite set. So infinite, if I would say, is something which is not finite. So if the number of elements in a set is not finite, in the sense that you are not able to count them, or you're not able to confidently say that how many elements are going to be there in that set, in that case you would safely say that yes, it is going to be an infinite set. Okay, so let me give you an example. So let's take the set of whole numbers. If you remember, in the first session that we had done, we had seen so many special sets like your whole number, natural number, real number, and so on. So all of them were your infinite sets. So again, your whole number starts from 0. It has a minimum, goes on 1, 2, 3, and so on. But they are not countable. We cannot say confidently, okay, these many elements are there in the whole number set. Therefore, this set we can say has infinite number of elements, and that's what makes it an infinite set. However, let's see the last type of the set, which is finite set. And as you know already, the name finite itself suggests that it is going to have countable number of elements. Either it can be 0 also. We in any case are able to count the number of elements which are present in that set. So if I have a set, for example, x, such that x is going to be an integer and lying between -1 and 2, in that case you know that the set is going to have only these 4 elements. So the number of elements you can count 1, 2, 3, 4. That is what is the cardinality of this set X. It has 4 elements and therefore it is a finite set. Let's take an example of classifying sets as finite and infinite. These are the kind of questions that you can expect in your exam from the topic of finite and infinite sets. So let's discuss a few of them one by one. So I'm going to take here A part, and I'm going to also take here D part. Yeah. Remaining all are very easy. You can read through and understand easily whether they are finite or infinite. So the first one here is the set of all x such that x is belonging to n and x is less than 100. Yeah, so we are taking all those natural numbers which have a restriction. They have to be less than 100. So definitely we will stop at the value 99 and we can count starting from 1 till 99. There are going to be 99 natural numbers which will satisfy the condition of this set and are less than 100. Therefore, in that case, we could say that this set is a finite set. Let's see D part also. Here the set is defined in the descriptive form, in the form of this sentence, that it is the set of people in your immediate family. So obviously when it comes to your family, you have different family members and you can count them. So this set is going to be a finite set, as you will have some specific number. It may be 5, 10, 15, whatever, but in your immediate family you are going to be having countable number of members or a finite number. So that is all about the examples on finite and infinite set. Okay, so let's now solve one question together. I have taken here 2 parts. And we have to state whether the following 2 sets which are given to you are finite or infinite. So I begin with the first one. So in this case you are defined, let me just name this set with a capital letter. So I'm taking set A for the first one and we are going to take set B, capital B, for the second one. So this is in set builder notation, the set of all x such that x belongs to natural numbers and x is even. So there is a condition. So can I say this set is going to be of all x such that x is a multiple of 2? That's why it is going to be even. Yeah, and n belongs to natural numbers. So I have written it in this way. And if I just change it to roster form, if I just trying to list some of the elements, then I can say that the minimum would be definitely when n is 1. So 2, then 4, then 6, 8, 10 and so on. Now why I have put these ... because it is going to be infinite. The elements are going to continue in that similar way because you have the set of natural numbers, and you already know that natural number set is an infinite set. So it is going to continue, and hence my set A, which is coming from the set of natural numbers, all these even numbers, is also going to be an infinite set. Amazing. Okay, let's try the next one, which is on the set B. So I'm defining my set B. It's clearly given to you with the elements listed. So the minimum is 1. It starts from 1, 2, 3. It's going on, and it also has the maximum element listed here. So you have just listed in this part all the elements. So I hope you all can see that very clearly, that it has a minimum it also has a maximum, and in between it has some elements. Now we don't need to be sure how many elements are there or the number, but at least we can say that these are countable number of elements. So if they are countable, you can definitely count them, and you could safely say that the set B that you have got is a finite set. So that completes the example. I hope the concept of finite and infinite set is clear to all of you. It is time for all my dear students to try yourself some practice problem to check for your understanding. So I have given here on this slide two questions, two sets in fact. I want you to check whether they are finite or infinite sets, and always when you're solving a question, give the reason why you say that. So please try and check your answer. You may put your answers in the comments below attached to the video, and I will give you the correct response after that. End of today's session, let us summarize what we learned. So in the session today, we learned about three types of sets. We started with the empty set or the null set or the void set which has no elements. Then we went to finite set, the set which is having countable number of elements, so we can actually count how many elements are there in a finite set. And the opposite of finite set is your infinite set, in which you cannot count the number of elements. Last slide for today before we end the session. So I'm sure that you all understood the concept of these three different types of set very nicely. If you have any queries or comments based on the video and on this topic, feel free to put it in the comments. Until next time, see you in the next session. And don't forget to like, share and subscribe my channel, Mathematics Made Easy, for more and more math videos. Bye students.